This is What the Hack 15's check-in number 6, where we outline our progress this week. Our work this week consisted of continuing the 6 phases outlined in the brainstorming and UI creation overview from week 5. Specifically, we conducted an exercise to establish priorities in the design process to refine the brainstorming output of ideas. We also finalized the medium fidelity prototype and began to program the logic that powers our Android CPR application. Finally, we created a GitHub repository for collaboration.
To recap the brainstorming and user interface selection plan timeline, we first began with individual brainstorming activities in week 4 and 5. This resulted in the identification of 15 ideas that would proceed to the next step for further evaluation. With these 15 ideas, we performed a feasibility analysis using a survey that each of the 4 members of the group took. This aided in the group finding which priorities to focus on the most. The next steps in the design process are finalizing the medium fidelity prototype, evaluating the prototype, and implementing the design.
Our feasibility analysis survey asked each group member to rank the 15 brainstorming ideas that came out of the previous design phase in terms of priority. Each member picked the top 6 that they thought were the most important comparatively to focus on in the early stages of prototype design. This resulted in 11 priorities to focus on in refining the first prototype. These 11 priorities were arranged into 4 categories: core elements, feedback elements, functional elements, and teaching elements.
The core elements consist of the parts of the design that are foundational to the rest of the design, such as the orientation of how the content is displayed supporting both landscape and portrait, preventing accidental locks during compressions by preventing lock and power button presses during compressions, and a start screen where the user can choose target depth and BPM for practice. Feedback elements are portions of the interface that tell the user what to expect or how to interpret what just happened, which includes vibration to speed up or slow down, and audio pings and buzzes upon compressions, and a summary results screen showing performance and compression quality. Functional elements are ones that relate to what features the first prototype will have, which are slow mode and allowing the user to toggle continuous measurements or set a specific length of time. Teaching elements are the gamification concept, which leverages users' consistent knowledge of games such as Guitar Hero or dance games to understand when to compress, as well as a tutorial on how to provide compressions during practice.
After a wireframe was created using Figma, we are now able to evaluate the first prototype using Don Norman's principles of interaction design. The first principle, visibility, is met with the 4 buttons on the start page: toggling compression summary status after each 10 compressions, toggling slow mode, viewing the tutorial, and toggling continuous measurement, keeping all of the possible options visible. For feedback, the compression timing corresponds to 3 colors of falling circles, which are considered a compression when compressed as the circle touches the center line. The colors are blue for an upcoming compression, red for a missed compression, and green for a successful compression. Too shallow or too deep compressions are stated with plain text, and good or bad compressions are also stated with green text or red color. One area where a constraint could be useful is graying out the measurement window slider and the continuous measurement button is toggled, helping to guide the user on what to expect when practicing. For mapping, the waves of compression in a red graphic on the top of the screen is a great way for users to see how far or close apart their compressions are, as well as the intensity of the compressions in an intuitive way. Consistency plays a crucial role in having all of the buttons be toggles, as well as leveraging the conceptual knowledge of games like Guitar Hero and the gamification elements of the app. Lastly, the affordance of telling the user where to hold the phone using a representation of 2 hands is present to help the user quickly understand what to do when using the app.
Concluding the evaluation of the first prototype, we observed that the wireframe does a good job of meeting Don Norman's usability principles. One area of improvement identified is to implement a constraint that grays out the time selection if the continuous compression button is toggled. The next step for this prototype is to create it in Android Studio. Once an interactive, functional prototype is created, we'll evaluate it for feasibility and functionality.
In the second half of this week's work, we began the first portion of implementing the calculation and application logic in Android Studio by translating what was developed in Python for the early phases of the project in order to calculate a compression's depth and rate, as well as magnitude, into Java. Several Java classes were made in Android Studio this week. The first class being Moving Average Filter, which filters magnitude according to window size and maintains an array of collected filtered magnitudes.
Compression depth is handled using the integration method outlined in Check-in 5 and the halftime update. This method also calls another method, convert compressions to inches, to show the depth in inches. Lastly, the get start and end indices method uses 3 conditions to determine if a threshold has been met to capture a compression cycle that is used in the compression depth measurement formula. One significant change to note is that all previous methods developed in Python were redesigned to track compressions from a retrospective look-back method, where data was pre-recorded in chunks, to a real-time analysis that uses a small rolling window of the sensor data to make compression calculations. This concludes our work done this week. Next week, we will continue to refine and test the back-end compression counting and depth calculating code, as well as begin creating the UI wireframe that was made in Figma to the Android app in Android Studio, making considerations on connecting the application logic started this week to a front-end interface.